Welcome to today's micro lecture. Today we're going to take a short look at ATP and how that produces energy for us, where we get the energy from that molecule, and why it's considered the major currency used in energy transfer for driving reactions in your body. If we look at the ATP molecule, we see it's comprised of three different sections. We have the adenine section, which is this area right here, comprised of the blue and the black balls that we see there. That adenine is attached to a ribose, a ring sugar that we see here. And then attached to our sugar, we have three phosphate groups. And those phosphate groups are held together with the bonds represented by the white lines we see here in this model. Now, when we need energy to drive a reaction, we can break the bond between our phosphate groups to release the energy, the potential energy, that's stored in that bond, so that as we break one off, we get free energy. So we go from ATP down to ADP, adenosine diphosphate. Now we have a little bit less energy stored here. There's lower potential energy because we released a lot of that potential energy as kinetic energy when we broke off our first phosphate group. Now your body can do a couple of different things. It can take ADP and reattach a new phosphate group to it for future use, or it can use a little bit more of the energy stored in here by breaking off the second phosphate group so that we are now down to AMP, or adenosine monophosphate. So the energy, that potential energy that's stored in those bonds associated with those phosphate molecules, is the energy storage system that we use to drive essentially all of the reactions that your body needs. So I hope that helps you understand a little bit about ATP, and we'll talk again soon.